Okay, in this video we're going to define a basic rebar shape, and what I will do to illustrate, I'll just drag my little PDF sketch across. So the idea is to create a double L bar but in three different sort of arrangements. So basically this is the same shape. It's got three legs defined by three dimensions, but it's sort of different in the sense that here we've got the middle leg, the B leg, the longer leg. Yeah, it's the shorter, but the A and the C varies. And then thirdly, we've got the B as the shorter leg and the A and the C is longer, but they are equal. This one we'll regard as the default, where in case it doesn't fit into that or this shape, it has to go into this shape. So what we will do to do that is not tie A and C to being equal, but to be whatever dimension. So in other words, this one can be slightly longer than that one, or this one can be slightly longer than that one. All right, so with that in mind, let's just go back to Tekla. So in Tekla, I've got three slabs, and if I go Control 2, we can see that there's no reinforcement. So let's just place some reinforcement, and I will go to a more visible bar. So let's just select the 20 again, 20 millimeter bar. So for the first one, I will just hover over and I'll undo the top to give us that basic U shape and say OK. So that's the first shape. The second shape, we will undo that one, but what we'll do is we'll drag this icon a little bit down to create a shape that looks something like that. And lastly, we will create one with equal legs at the end. Okay. So these are the three shapes that we want to define. Now, if I click on this and I say right click, inquire, it comes up with the shape LL. And if we look at our rebar shape catalog, if I go in here and I say shape manager, we will see it's defined as LL, and it's got some dimensions in it. So what we can do in this case is we can I think let's start by just looking at what we've got here. Maybe for the sake of this exercise, we'll let's just delete that bar. I think for the sake of this site, let's go to the shape catalog and go pick LL and let's remove it. So what will happen now is I'll go to the model bars. Do you want to save it? Let's just say cancel there. It's got the environment. So in order to save it in the model, I've got to go model folder, save as, same name, save. Now it's changed to the model folder. So what I can do then is just close. And if I now reload the model quickly, say open, recent, same model, for it to read the new XML file, rebar shape file from the model folder as opposed to the environment, because I don't want to change the environment file at the moment. But this is something you can do. You can develop this file in the model, and once you're happy with all the shape codes, you can roll it out to your environment or to your firm folder, company setups, whatever you want to do. Okay, so now we've got it reloaded. So if I click on that bar now and I say right click, inquire, it will still come up with an LL. And if I go to the rebar shape manager, pick the bar and say get selected, it comes up with non-standard shape. Okay, now why did it come up with a LL in the report? It's because although this shape LL has been deleted from the rebar shape catalog, manager's catalog, it's still present in the group's rebar shape catalog, which is a different catalog. So you can see LL is still present there. And also if we go to the rebar sets and we go to rebar placing, you'll see in this catalog it's still present there. So you'll have to remove them from those two if you totally want to redefine them. But for this exercise, we'll stick with the rebar shape manager, because as soon as we define this shape in the rebar shape manager, it will not use those two anymore. That's just a fallback sort of catalog. It will not use that anymore, because in the Control E, which is your advanced options, if you just type in your rebar and we go search all categories, if we go down the bottom, so from the previous videos, we've defined this as being true, because we want to use the length and the weight, and in here we say we do want to use the rebar shape rule. So if this shape does not exist in the rebar shape rules catalog, it will revert back to the defaults, which is the others. But if it exists, it will always take this shape. Okay, so a bit of background there. Okay, so let's start. So the first thing we want to do is let's just define this bar in the rebar shape catalog. And so what I'll do is I'll click on the bar, go to the rebar shape manager, pick the non-standard bar. And the first thing you need to do is just make sure it's reading from the model. It is reading from the model. First thing we want to do is give it a name. So we'll call this an LL1 as per our sketch and say add. Now it's added that as a shape. So that shape, what we can do now is in column A, we can define leg 1. So all the way down to L1. Now, just note that S1 and L1 is two different. S1 is a straight length value and L1 is the full leg value. And you can see there's quite a difference there. What we want is the L1. Now, the difference between L1 and S1 in terms of the sketch is S1 will go from the start here to where it meets the arc. That is S1, where L1 will be from the start of the bar till the end of the leg. So it's perpendicular to 2. That's where the leg ends. That is the L1 value. I might just at this stage before we define, so let's do the other two legs first and then we'll go on to, so we want leg 2 as a B value and we want leg 3 as a C value. And that is obviously all coming from this little sketch that we had in here. You see LL1, the A, the B, and the C value. All right. So what we will do now, next is maybe what we can do now is let's just update that and save it. What we can do now is just go into a bit of an explanation of what the rules is already. Well, first thing is angle 1. It's automatically added a rule that angle 1 is equal to 90. Where does angle 1 come from? Well, if you take the first leg and you extend the line past leg 2, the angle that it forms from that extension line, imagine the extension line through that angle that it forms there between the extension of leg 1 and the following leg is called angle 1. The same with angle 2. If you take leg 2 and you extend it past the following leg, that angle that it forms there, outside angle, is defined as angle 2. Now the twist angle 2 is, if you look at the first two legs, leg 1 and leg 2, imagine there's a plate here and that plate is a plane. That is your, how can I say, origin plane of this particular bar. Now the second leg, in this case, if I form a plane between leg 2 and leg 3, those two planes will be coplanular, which means the angle will be 0. But if this was, for instance, a 3D bar where it's pointing either in and out the screen, there will be a twist angle of either plus 90 or minus 90 degrees. Now, if I just go back to my edge and we just look at the rebar shape rules manually, we can see here, this is what I'm talking about. So this first leg of the bar and the second leg of the bar gives you a plane created by leg 1 and 2, and that is sort of the origin or the first plane of the bar. Now for the twist angle, for this angle, now in this case you can see this bar is in line with that, so the twist angle in this case will be 0. But if you look at this next example here, we've got our original plane red there that's formed by leg 1 and leg 2. Now you can see this is bent outwards, so it forms these two planes and it forms a new plane here. Now the difference between this plane and that plane is a 90-degree plus angle because of the rotation. You see the notation here, it goes clockwise plus positive. So I think that's the first thing. The second thing that I want to look at is the radius. Now if I just on any open column right click, then you'll see there's a radius 1, which is the first radius, it's the first corner, is 50. Radius 2 is 50. Now there's a rule in Tekla that says if all the radiuses 1, 2, 3, 4, 5, 6, no matter how many radiuses are, if they all equal, they have the same value, then Rx is 50. If one of them are different, then Rx is 0. So therefore it's got a rule here that says R asterisk, which is Rx, is equal to R1, which means all the radiuses are equal to the standard radius, okay? And also, just to confirm that, if you go to the online help again, you can see here that it clearly describes that Rx asterisk is the value of the bending radius when all bendings have equal radius. So if they're all the same, Rx has a value and that value will be equal to the value of the radiuses. If one of them are different, then Rx gets a 0 value. So you can use it to check if a bar conforms with all standard radiuses, or is this going to be a special bar because it's got a larger or a smaller radius for whatever reason. All right. So that is basically the auto-generated rules for this bar that Tekla came up with, and by default we've got 1, 2, and 3. So that defines the leg. So if I just that's now saved. If we close it and right-click, we inquire that bar now. We can now see we've got an A, a B, and a C value. We still have a length there. Now, if we look at the length, if we add these up together, so that's 700. So let me just grab my calculator out just so it's visible to everybody. So if I go 1450 and I say plus 350 plus 350, we get 2150. So we can see that the legs, the bar legs, the sum of the leg lengths, which is these, are not equal to what I'm seeing here compared to what we work out, which implies that Tekla is still using the center line length to calculate the length and the weight. So to fix that on that shape, what we will do is click on the bar and we go to RebarShapeManager, and if we look at what we've got in here, so if I just have to select the bar first, so if we look at what we've got in here, we've got no value in L, so there we've got to tell Tekla what length to use. So in this case we want to use the sum of the leg lengths. Okay, and you can immediately see that now sort of coincides with what we worked out with the calculator. And if we go to the weight, what we want to do here is we want to key in a formula and tell Tekla that we want to take the sum of the leg lengths and we want to multiply it by the weight per length of the bar. Okay, and now we can see we've got a more accurate weight there. So if we update our catalog and we say save, close, if we now do an inquiry on that bar, we will now see we've got the correct length and we have the correct weight for this bar. All right, so now if we look at the second bar in the series and we right click and we say inquire, it's picking it up as an LL1. Because if we look at the rules of LL1, all it says is that if we go to RebarShapeManager, we look at LL1, just make sure it's it. So if we look at this rule, all we've got is that angle 1 is 90 degrees, angle 2 is 90 degrees, twist angle is 0 degrees, and all the radiuses are the same. So it's not distinguishing the fact that this bar, the second leg is longer than the first and the third leg. Yeah, the second leg is shorter than the first and the third leg. So we need to add a rule by the first bar. So what we can do here is just click on the first one and say get bar, get selected. So we've got all that bars. So click on the first one. And in here we can say, let's add a rule where on this rule we say that leg number 2 should be greater or equal to leg number 1. Okay. And also what we can do is we can say that leg number 2 should be greater or equal to leg number 3. We say okay. So with those two rules, what we can do then say is update, save, quit. Now if we go to inquiry of this bar, we can see that we still have an LL1. And if we go and look at the second bar now, if we right click and we look at inquiry, it's defaulting back to the default catalog because it's not recognizing that bar shape in the rebar shape catalog. So to define this one, what we can do is go to the rebar shape. It will come up with a non-standard. So in this case, we can give it a LL2 annotation. We say add. So now it's got the bar in there. So all we have to do again is just define the column. So it's L1 is leg 1. The B value is leg 2. And the C value is leg 3. And then for the L again, we're going to use the sum of the leg lengths. And for the weight, we're going to add, oops, let me just drag this in a bit so it pops up on our screen. Yeah, we're going to add a formula, and the formula we're going to say we want to take the SLL and we want to multiply it by the WPL, weight per length. Okay, so it's calculating the bar there. We can update this. And now what the rules, so these rules are still the auto-generated rules. So we've got to add more rules here. And the first rule I want to add here is to say that leg A is not equal to B. Or we can say that leg B, well, what we can say, I think the first thing we've got to say here is that like leg 1 and 3 are not equal. Okay, that is the first fact. So what we can say is like leg 1 is not equal, does not equal leg 3. Okay, that's the first rule. So already that one will be eliminated because, well, those two can be equal. So we'll have to add another rule, and another rule would be to define that this one is shorter than those two. So what we can do is say leg 2, L2 is less than L1. Okay, and we can also say that L2 is less than L3, if I can find it. Okay, we can update this, save it, and close it. And now if we click on this bar and we right click and we say inquire, it comes up with an LL2, so it successfully identified that bar as LL2. And if we click on this one and we right click and we say inquire, it's an LL1, so it's now successfully differentiating between those two different shapes. If I go to this one and I inquire, we're back to the LL, which is the default catalogs, because that shape is not present in the Rebar Shape Manager. If we go to the Rebar Shape Manager, we can see it comes up with a non-standard standard. So the first thing we're going to do is we're going to define this as LL3 in this case, and we're going to add it as a shape. So it's now recognizing it. And as per before, we're going to define leg 1 and leg 2 and leg 3 to the A, B, and C column. We're also going to say that leg L is equal to the sum of the leg lengths. And then for the weight calculation, we're going to say formula. We're going to say sum of the leg lengths times the weight per length, and that works out the weight of the bar correctly. So now we can update that, and now we just need to add some rules. So the first rule we're going to say is we're going to say that if I can just drag down this short leg here, this leg is smaller than A, and this leg is smaller than that one. So we're going to say that leg 2 is less than leg 1. Okay, and we're going to add another one where we're going to say leg 2 is less than leg 3. So it's pretty much similar to what we did before. No, we won't add another one. If I can say update, save. Okay, so the big difference between this one now, if I just go and inquire this one, which is now LL2, and this one, which should be LL3, LL3 is the fact that if we look at the Rebar Shape Manager again, here we've got defined that leg 2 is less than leg 1, which is this leg 2 is less than leg 1, and leg 2 is less than leg 3, this one. And also, just to make sure, we can also say that leg 1 is equal to leg 3. In that case, we sort of create a situation where where in case this one leg gets dragged shorter, it's not LL3 anymore, it's going to be this one. So if I say save, because on this one we said that one and that one is not equal. Save that, closed. All right, so now that we've defined these bars correctly, let's just go to another view from the side, and let me just copy linear. I'll just copy this to say there somewhere, copy, clear. And what we will do is we'll just manipulate these bars a little bit. So what I'll do is I'll take the concrete and I will drag the top up so it's unequal. Let's drag it a little bit more. And then maybe what we can do is just drag this side a little bit smaller. So we can see we don't have that shape anymore. This shape should more be equal to that one. So if we click on this one now, right click inquire, we do get LL3. Okay, so what we can also do is if we take this one and we drag it out, maybe what we can do is let's drag this out further again so it's longer. So if we look at this one, this is longer than these two. Inquire, we're now back to an LL1, which is as per definition this. And if we do take this one and we say, let me just click on the bar itself. And I think in here we can move, add, delete, modify the spacings, edit the guideline properties. It's probably easier if we just do this. So if I take this bar and I go crossing bar and I pop that in there and I undo this and I drag that down to make it a bit shorter, we can say okay. Now this bar should be, if we go inquire this one, equal to LL1. And why not this one? Because if we look at, so this is actually a very good example. Let's have a look at this. So why is this bar that we've created here equal to this one and not this one? The reason for that is in this one we've created a rule that says that the middle length must be longer than the first or the last, which is the case here. We've also got a rule that says that this one is not equal to that one, which is true in this case. So if we go to the Rebar Shape Manager and we just quickly look at it, we click on this one. So let's just have a look here quickly. If I do this, so here we've got a rule that says leg 2, which is this middle leg, as you can see from the switch here, is greater or equal to leg 1, and that is the case here. And if we say leg 2 is greater or equal to leg 3 is the case here. But in both cases, leg 2 will be greater or equal. So whereas if we click on this one and we say get value, and if we look at L2, in this one, we said that leg 1 does not equal leg 3. So those two cannot be equal, which is also true in this one. But we also said that leg 2 must be smaller than 1 and it also must be smaller than 3. So that's sort of a, I'm sure there's a different configuration. There will definitely be different configurations you can come up with that distinguishes between the three similar shapes, but as different shape codes that you can come up with. This is just one example. You know, I mean, we could possibly let's prove the theory. If we say leg 1 and 2 is not equal. So let's delete that rule, delete that rule, and delete that rule, and we add a rule and we say that leg 1, where is it now? Leg 1 does not equal leg 2. So you can see from the values in the brackets here that that's going to be true. So okay, and we're going to say update. We say save, close. So in this case, if we click on this bar, we can say inquire. We can see it's an LL1, which is correct. This case, different rules. Inquire, LL1, it's correct. This one, yeah, inquire is an LL2, and let's just have a look at the rules here, shape rules. So in this case, we've got length 1 does not equal 2. That is true. And in this case, we still have the original rule of, so it's an LL3. So if we go to the shape manager, in this case, we also have the rule that leg 2 is smaller than leg 1, and leg 2 is smaller than leg 3. And even if we say leg 1 equals leg 3, leg 1, you know, you really need, well, to be quite honest, you can delete that one. If we delete the second one, if we say leg 2, which is this one, is less than leg 1, and leg 1 is equal to leg 3, then those two must be equal. So you don't even have to state it there. So you can just update that and save, close. And now if we click on that one, right click, inquire, we still have LL3. So it's just sort of, you know, what works for you. There's many ways to differentiate between these bars depending on how you set up the rules, but I've just gone through two different settings of rules that give us the same result. But so this is sort of the basic introduction on how you set up a bar, how you define its leg lengths, and how you set up the rules to distinguish between the different shapes. I just think that in a follow-up video, I think what we will do is we will also now address when we have sloped legs, and you know, hooks. We'll deal with hooks, and if we just right click on here, you'll see there's a whole lot of rules here that deal with leg to leg distances, long leg distances, offset from leg distances, and custom properties. So we'll have a look at that and see how it how that works. But we've really worked with angles. We know what about the twist angles. That's really applicable to 3D bars. We know how to deal with the radiuses and the RX now. That's been discussed. The bending length, BL1, BL2. Although they're present in a simple bar like that, they're more relevant, I think when it comes to bigger radiuses and you want to work out the radius length or the arc length or whatever for some reason. We've dealt with S1 and L1 values, which is similar to S2, L2. It's the difference between the full leg and just the straight length before, not including the arc and so forth. So we'll deal with the bottom part of this in the next video. So hopefully that was helpful, and I'll see you in the next video.